So in the last unit, what we mostly talked about were expressions. And you can simplify expressions, so you can combine like terms or distribute things, but there's no equal sign, and so you can't solve an expression. What we're going to be talking about now are equations which have an equal sign, and with an equation, you can often solve them by finding x. As long as you do the same thing to both sides of an equation, it stays balanced, and so equations are actually, I think, easier to work with. Just keep in mind, equations work like a balance. If you do something to one side, you have to do that exact same thing to the other side to keep it balanced. Like, for example, we all know that 3 plus 2 is 5, and 5 equals 5. If I were going to add another one to this side, that would make the side a little heavier, so now I need to add one to this side. Or if I were going to like square this side, I would need to also square this side. So 36 equals 36. So just whatever you do to one side, do the other. You've got to keep it balanced. Also, this allows us to solve for missing variables, like x here. Like, what would I need to put in this box plus 2 to give me 7? Well, the answer is 5. If you weren't sure about that, you could always just get x by itself by taking 2 away. Take away 2 of those balls, and you get x equals 5. This literally tells me the value of x should be equal to 5. And that makes sense, because 5 plus 2 does equal 7. So as you're solving these equations, keep this stuff in mind. And you don't need to write these down because they're going to be on a paper that I'll give you on the practice. Keep both sides of the equation balanced, so what you do to one side, do to the other. If you can, you may need to combine like terms or distribute like we've already practiced. To eliminate fractions, it's often helpful to multiply both sides by the denominator of the fraction so that you don't have a fraction anymore. And if you ever have multiple variables, like an x over here and an x over here, you can only have one x to solve for it, so move everything to the same side, get the constants to the other side, and you'll see some examples of this in a second. All right, I did want to mention that as we're solving these, basically you're just trying to get the variable by itself. So to do that, you need to move everything away from the variable, like get it out of its space. And what you're going to do is backwards of the order of operations. Since we're undoing things, you work backwards. So adding and subtracting, we get rid of first, then multiplying and dividing, and then exponents, then anything in parentheses. So the first thing I need to get rid of here is the minus 8. That's subtraction. So we'll add 8. Just do the opposite. That'll just get rid of it. Since I added 8 to this side, I gotta add 8 to this side, which gives me 40. 32 plus 8 is 40. And now I'm left with this. I'm almost done. To get b by itself, I need to get rid of the minus 10. But be careful, this is not b minus 10, so I don't need to add 10 here. What's happening is it's negative 10 times the b. So since this is multiplication, to get rid of it, I need to divide by the negative 10. Again, division is the opposite of multiplication. That's why I divided. So now I have b by itself. b equals 40 over negative 10 is negative 4. That's my answer. Solving equations is pretty nice because you can always check your work. If I do negative 4 in here for b, so if I do negative 8 minus 10 times negative 4, put it in for b, will that actually give me 32? And it should. On this one, we're trying to find a, or solve for a. So 2a minus 6 equals 5a. Notice I've got a's over here and I have a's over here. I need to get them on the same side so I can combine them. It doesn't matter which side. I personally like to keep it positive, so I might subtract 2a instead of subtracting the 5a, but just move move them to the same side. What I mean by that is, to move the 2a over here, I can just subtract 2a from both sides so that it's not on this side anymore, it's on this side. What is 5a minus 2a? That would be 3a. The negative 6 stays, and that's good. Now, see how now these have combined to make just 1a? And so now, just to get a by itself, I'll divide by 3 and be done. So negative 2 is equal to a. Sorry, it looks like a 9, but that's an a. Again, you can check your work. Does 2 times negative 2 minus 6 really equal 5 times negative 2? And it should. Here's a kind of longer example. So first of all, I have this big long equation, and then what it's asking me for is 2y plus 1. I don't know what y is. And so in order to answer this question, I first need to solve this for y, and then I can plug it in here. So to solve for y, there's a couple different things you could do. The first thing I'm going to do is just combine like terms, because I see I have a 2y plus 5y, which is 7y minus 4. Over here I've got 4 plus 5, which is 9. So I'm just combining some like terms there. Now you'll notice I've got some y's over here and some y's over here. I need to get them to the same side. Doesn't matter which one. I might move this one over here just to keep it positive. So to get rid of minus 3y, we'll add 3y to both sides so that I get rid of that one, and I just have y's over here. 7 plus 3 is 10y. Everything else stays the same. And now it's kind of just a simple equation to solve. I will add 4, so 10y equals 13, and then to get rid of 10 times y, I'll divide by 10. So y equals, you can just leave it as 13 tenths because that doesn't simplify, or you could put 1.3 because dividing by 10 is the same as just moving the decimal place. So either of those are fine. Oh, sorry, that wasn't my answer. The question asks for 2y plus 1. And so to do that, I'm going to need to plug in what I got, which was 1.3 for y. So 2 times this y value plus 1. So that's 2.6 plus 1, which is 3.6. Okay, let's try another one. This one's a little weird. This one has x's in it and a t. Sorry, that looks kind of weird, but I like to put a little hook on the t so it doesn't look like a plus sign. But and the problem asks me to solve for t. So just like you always do when you solve any equation, you're just going to try to get the variable by itself. And so it doesn't matter that I have these other x's in here. I'm just trying to get t by itself. I'm solving for t, meaning I got to move everything away from t. This needs to happen first because adding is last in the order of operations, so it'll come first as we undo things. So subtract the 4x from both sides to get just 3t left. That's going to be 6 minus 2x and minus 4x makes minus 6x. And finally, to solve for t, this is 3 times t, so I'll divide by 3. And divide this entire side by a 3. What you do to this side, you have to do to this side. And now I have t by itself. I solved for t. This we can simplify a bit by dividing them both by the 3. So 6 over 3 is 2, and minus 6 over 3 is minus 2x. And that's my answer because I have t by itself. Notice that there were some x's left in the answer, and that's okay because it just asked me to solve for t. So there's nothing I can do about the x, it's just gonna have to hang out there.